That's not revealing. Oh, shit. What we have here. Goes music. That's how that works. Huh. Okay. Monoamine oxidase comprising isoenzymes MAO-B is crucial for oxidative deamination of neurotransmitters such as dopamine, noradrenaline, and serotonin. The isoenzymes encoded by separate genes on the X chromosome. Maybe I should pause this. I don't even know if it goes through. The isoenzymes encoded by separate genes on the X chromosome are flavoproteins, each containing an electron acceptor, flavin adenine dinucleotide FAD. The active sites of these enzymes contain key tyrosine residues that help orient the substrate, facilitating its interaction with FAD. Despite sharing structural similarities in their catalytic centers, MAO-A and MAO-B exhibit different intrinsic activities with any given substrate as shown in Table 1. Kinematic parameters of MAO-dependent oxidation of common neurotransmitters. Yes. KCAT. KM. Wow. Okay, benzolamine, phenylethylamine, serotonin 5-HT. Parkinson's disease MAO-B inhibitors like sulfonamide are used to prevent the breakdown of dopamine, thereby enhancing its availability and alleviating motor symptoms associated with dopamine deficiency. Gosh, this is a dense one. By selectively inhibiting MAO-B, these drugs help manage the progression of symptoms of Parkinson's disease, improving the quality of life for patients. The structures of several MAO inhibitors are shown. Great. Irreversible A and reversible B. Okay. Natural compounds have also been investigated for their MAO inhibitory properties. Wow, this is just a mouthful. For instance, curcumin found in turmeric and ellagic acid found in various fruits and berries. I mean, this is just brutal. Let's just read the question. Which of the following statements is true regarding the affinity for MAO enzymes for substrates tested according to the data in Table 1? Regarding the affinity of MAO enzymes. Okay, so we're talking about affinity. So how much these enzymes want to act on the substrate. So thinking amino acids in the active sites of the pocket. Okay. Before I look at Table 1 again, let's just see if the substrate says MAO-B and phenylethylamine. Both MAO enzymes high affinity for benzolamine, MAO-A for phenylethylamine. So we want to look at benzolamine and phenylethylamine. Affinity cannot be inferred. I don't think I've seen a question yet where an answer that says none of these is right is correct, but we'll see. I'm still holding my breath. Okay, Table 1, MAO-A and MAO-B. Okay, got a high Km for benzolamine. And the highest for MAO-B is also benzolamine. But we have to consider the catalyst effects. Let's see. Km times Kcat over Km will give us Kcat. So that's going to be very small. That's going to be larger. That's going to be larger. Okay. That's going to be large. Serotonin 5-HT would be very small. Okay. Phenolmethylamine. Substrates tested, both MAO enzymes exhibit the highest affinity for benzylamine, which not if we consider the catalyst. That's in millimolar per second. I don't know. I think I'm just going to have to cheat on this one, but my guess would be this one. So there's something I'm not considering. .75. I don't know. I mean, I need to see how they expect me to figure this out, really. Km value is the measure of the affinity. I knew that. Enzymes with high Km have a lower affinity for their substrate. Whereas those with a low Km have a high affinity. So we're not considering the catalytic values yet. So does that make sense? Now B 0.067 times 53 is like, I don't know, 2.5. Oh wait, I'm not multiplying these, gosh. Okay, the smallest number is there. For MAO-A, the smallest number is serotonin. That was not an option. We're looking for true statements, so okay, that makes sense. Okay. All right. In the presence of which substrate is the catalytic efficiency of MAO-A higher than that of MAO-B? Okay. So if we're still playing it by the low value, this is going to give us a small number. It's going to give us 0.02. 0.75. I don't even know if I should be multiplying these together. If it's just lower than benzylamine and phenylethylamine. Multiplying them, Serotonin. I don't know. Serotonin isn't an option. An ideal enzyme with a high catalytic efficiency would be one that's very high velocity, very high affinity. Okay. The half-life of MAO-B in the brain is 30 to 40 days. It's PD defined. Parkinson's disease. Okay. Okay, so these are inactivators. These are reversible inhibitors. Double reciprocal Lineweaver Burke. Okay. The effect of irreversible drugs is long-lasting. It doesn't. Okay, so that was literally just like a logical statement. Okay. I mean, this is like probably one of the hardest ones I've had to do in this whole, in the past 2 units or something. This is like the hardest one I've seen. The inhibitors, I mean, maybe it's just because I still haven't finished biochemistry, the second part, but the inhibitors, phenylzyme, tranylcypromine, isatin. Functional groups, really. Phenylzine, and here it says phenazine. That's kind of funny. Functional groups. There's a phenol. There is various amines, secondary, primary. That's all I'm really seeing common between them. Indol. Oh, respectively. Okay. Let's see. Phenol. Yes, that's an indol. I don't know what the heck that is. I think that's an indol, so I'm just gonna wing it. Okay. Am I just an idiot? Yep, I'm just an idiot. Cyclopropylamine. Hydrazine and cyclopropylamine. I mean, am I just blind? Hydrazine. I don't know, man. Oh. Whoops. Cyclopropylamine. Yes. spiral ring. But is it a spiral ring even if there's not a double bond? Yes. I mean, gosh darn, I'm doing terrible. The mode of inhibition of curcumin and pelagic acid towards LD is I mean, electron acceptor. Key tyrosine. Mm-hmm. Shit, I don't even know where it would say that. Presence of curcumin in figure 2 did not alter the Km value. Oh wow. That's right, I forgot all about this. Yeah. So if the Km in the Lineweaver burp doesn't change, it's non-competitive, huh? What doesn't change there is the 1 over V max. Which I don't even really remember what that means. The V max isn't changing. Is it competitive, I guess? Yeah, competitive business activities. This is crazy. The type of reaction shown in the figure below. What are the identities of the missing compounds? Oh boy. Did it tell me? Oxidative deamination. Okay, so deamination. Okay. So what would that be? NH2. NH3. Ammonia. We have an oxygen. Okay, gaining an oxygen. Losing an ammonia. Water and F8D. I like the look of that one. Although this is the same, but it's a different word. Oxidative deamination. Yeah. I don't know how I did that. Okay, let's see how this looks.